Welcome to Chapter 8 of the course on integrating Casambi Networks with the Adquio ecosystem. In this chapter, we will cover how to manage errors in Casambi Networks and how to relay these errors to devices that allow us to verify them. This will enable us to be aware when these errors are occurring. As you may recall from previous chapters, we had selected the condition variable and the online variable from our Lithernet. Let's revisit when we did this. We could also mark, for example, the online and condition fields in the devices, which would allow us to monitor if any of the network drivers or luminaires have errors, for example. Do you remember it more clearly now? So let's see how these variables work, and then how to make use of them through a small script. Firstly, the online variable allows us to know if this device 1 of the Casambi network, is connected to the network or not. If it has lost connection to the Casambi network, it would mean that this device has completely malfunctioned, has lost power, and is not communicating with the Casambi network. Therefore, this would be the first and most serious error. All right then, the first point. We can monitor the online variable for all devices in our network. Next, in the condition variable, we have the error codes that this driver or luminaire can provide us. These Casambi error codes are published, and we can manage them and understand what each one corresponds to. Let's take a look at them. As you can see, we have a series of error codes for some reason for OK, for nothing's wrong, for everything is fine. There are 3 different codes, as you can see in the first line. And then we have all the error codes that this Casambi network can return: overvoltage, overheating, misconfiguration, excessive consumption, because we have connected too many luminaires to a single driver, etc. So, by working with these variables, as we saw earlier, online and condition, we will be able to fully manage the integrity of our Casambi networks. Let's move on to scripts and see how to do this. We are going to create a new script, for example. Remember that in this context, special characters cannot be used. We cannot include spaces. So let's see how to use another method for working with events. Let's paste a small example here and examine it more closely. As you can see, we are still using the same philosophy of event.addListener. We still have our variable evif from event.value, and here in the middle is where we have the most interesting part. In this section, we are going to include the conditions that we want to be met for this event to be triggered. Therefore, it is extremely powerful because it allows us to manage all the incidents across all the Casambi networks we have connected in a single event. All right? So as you can see in these conditions, we have, just like in the example from the previous chapter, event name equals variable change. Next, we have the logical ND of JavaScript with 2 ampersands on. This means that this condition and this condition and this condition, all 3 must be met. Therefore, that event name corresponds to variable change, and the device code starts with. We'll write that next. Additionally, the variable code should be equal to. We'll write that too. In JavaScript conditions, you can use these conditions with double equals or triple equals. The main difference between the two is that with double equals, if the values being compared are in different variable types, for example, a string and an integer, and both contain the correct value, for example, a string that only contains a 1 and an integer whose value is 1. With double equals, it will indicate that this equality is true. On the other hand, if we use triple equals, in addition to checking that the values are equal, it also compares that the variable types are exactly the same. If they are not, the equality will not be satisfied. In this case, as we know perfectly well that event name is a string, we can also perfectly use triple equals because we are comparing it with a string, meaning a text string. All right, let's continue then. Device.code, in our case, is Lithernet followed by a number. Since we want this to work for all the Casambi networks we have connected, regardless of the number, we will specify that it should start with Lithernet, but won't include the number. All right? Here would be the 01, 02. Remember? We'll check it later in the devices. And here's the interesting part. Starts with. This is a function that strings, or text chains, have in JavaScript, which allows us to check if it starts with. Now we are going to use another one that tells us if it ends with. Or we even have one that indicates it contains. The function for ending with would be ends with, and the one for containing would be includes. Perfect. So, in the next case, instead of specifying that the variable code is equal to something specific, as in our case, the variables have the full name and what they are at the end, we will tell it that instead of equal, we will use ends with, followed by parentheses to pass the parameter. And in our case, the variable we want to monitor right now is the online variable. We will check if all this is written correctly, but let's see exactly what we are doing. We are creating an event that allows us, when the value of the online variable changes in any Lithernet on the network, to execute whatever is below here. Obviously, what are we going to do here? We will check if the online, which should always be set to 1, has changed to 0. If it has changed to 0, we can trigger an error message, and we can even specify which Lithernet device it occurred in, meaning in which Casambi network the error occurred and in which device it occurred, because we have it in the variable name. Let's save this, now that we've finished explaining it, and check if the variable names we've used for Lithernet and online are spelled exactly like that in the device. We save, go to Variables. Online, indeed, is written with a capital O. And Lithernet is also written with a capital L. We can even add an underscore because even if it were Lithernet 02, it would be Lithernet 02. All right. So we are now inside the event and know that this event will allow us to manage the online condition of all the devices in all the Casambi networks we are connected to. And we know that all the information comes in the EV variable. Therefore, as a first approach to this, we could do a logger.info, just like we saw in the previous chapter. ev.newValue, for example. We could indicate or show in our log below what value the variable is bringing us. Okay, but to make this richer, let's also extract the device name. For this, we will use, this would bring us the device name. And we also have the variable name. In our case, we won't use this because we already know that the variable we are filtering by is online. So it's redundant to show it here as well. So what we can do is, we know that our device name is something like Lithernet 01. Therefore, let's extract this number to indicate which network the error was found in. Agreed? So, we need the element 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We need element 10 and element 11. All right, so all we need to do here is put some brackets. We need element 10 plus. Copy this and say 11. With this, what we are going to say is, in our case, we have only one network, so this would show us 0 in the case that we filter, because this event was triggered because the online variable changed. Now we will include an if here to handle it only if this variable changes to 0. It will show us that 0 in the first line and show us the Casambi network number according to Lithernet where the error occurred. All right. We could also extract the device number in the Casambi network, as we also have it in the variable. In this variable, before the online, we have the number. We'll look at it now in devices so you can check it. We are working with the online. The number before the online is the device number in the Casambi network. So we could say, error in Casambi network X and in device Y, right? In this case, we won't do it, but we would do it exactly the same way, looking for the numbers that are in the middle of the variable to indicate exactly which device is failing. If we have them positioned on a map, we could go directly to that device to fix the problem. Let's go back to scripts and customize this error message a bit. To do this, we're going to tell it to handle only these errors if the device has gone offline. This means that yev.new value should be 0 because the normal value of the online variable in a Casambi network is 1. So we will do an if. Remember from the previous chapter, we will put a condition and then some content. This condition will be that ev.new value is equal to 0. If it is indeed 0, it means the device has gone offline. Let's include this. We won't add it anymore because we know that if we are here, it's because the device has gone offline. So, we place this curly brace at the end, and we have our if working. Let's improve this message a bit and write, error detected in Casambi network number. Leaving a space so that it doesn't stick together when displayed, and then the number of our Lithernet device. What this will do is show us an error message in our log indicating that a device in a Casambi network is failing. Next, let's see how to work with the condition variable instead of the online variable. This variable allows us to extract much more information about the type of error we are getting from that device in the Casambi network. So let's do the same thing we did with online. Let's remove this comment here. Let's copy this entire event so you can also see that you can manage multiple events in the same script. We will simply change online to condition. Let's delete all this, which was from the previous example. Now we know, because we previously saw a list, that ev.new value will bring us a series of values. We knew that 0 and 128, for example, meant that everything is fine, and we know there are other numbers that indicate the type of error occurring in that driver, luminaire, etc. So, what are we going to do? We are going to create a variable, txt, to contain the error message. We will call it, for example, txt, and we will say it is of alphanumeric type. And now, we are going to learn a new instruction, which is the switch instruction. The switch instruction has a parameter and, as always, curly braces. This parameter will be the content of the condition variable, which comes to us in ev.new value. Next, we will put all the checks we want to make with this variable, and this is done in the following way. With a case and a possible value, for example, 0. We put a colon and specify what we want to do. So txt is equal to OK. At the end of each line, we must always include a break because we don't want these verifications to continue. If the variable ev.new value contains a 0, it makes no sense to continue checking if it is, because it already fulfilled being 0, so it won't be any of the others. Therefore, all the instructions we put inside the switch, each check done with case, must always end with break. So, we know that 128 is also an all-good message, and, for example, 1 is driver overheating. Alright, semicolon. I'm going to create all of them so you can see how it looks and explain something else to you. Alright, we have them all now. So, what we can do now is display this error message but with its corresponding text. So we're going to do the following. We're going to do an if, because what we're not going to do is show an error message that says, OK. Therefore, we are only interested in showing this error message if what we are going to display is not OK. So, we will do an if as usual. Condition and content, and let's check that txt is different from OK. And what are we going to do inside the braces? Well, a logger.info txt, for example. This way, what we will get in our log, down here, is the error message that comes from the Casambi network of a specific device. But this time, we are going to do it completely so you can see everything we can get. In the previous event, we had obtained the Casambi network number, so we are going to take this piece from here and customize our message. Our message will be the following. Error in Casambi network number plus our Casambi network number. As you know, this event, exactly like the previous one, has the device name in the same variable, so we can keep using it. And now, to make this message complete, we should also include in which luminaire the error occurred, and then what the error was. Therefore, we have a message that shows that an error occurred in Casambi network number 3, device number X, and the error that occurred is this. A very comprehensive message. For this, then, we are going to obtain the device number. And as we mentioned in the previous event, the device number is in the variable name, and we need to extract the digits from the middle of the name. Let's see how we can do this. Variable code. This is where we have the complete variable name. Let's comment on it for a moment and go to the devices to see exactly where the number starts. We save it, go to variables, and in condition, we have the D. It's 0, 1, 2, 3, 4, 5, 6. It's the underscore. So, the device number starts from position 7. Well, simply, let's go back to scripts. And here we had variable code. So, we are going to load it into a variable to work more comfortably, such as variable code. For example, let's call our internal variable VC, variable code, and let's create another variable for our device number. We are going to call it device no. So, we know that from position 7 of VC, we have the first number in case it is only one digit. So, we are going to set that the first number will be VC7. And now, let's check if the next digit is numeric. And if it is numeric, we will append it to our variable. So, we are going to do an if here that tells us, as always, condition and content. This is a function that checks if what we have next is a number. Instead of char, we are going to use VC8 because it's the next character. This function returns the exact opposite of what we want. So since this function converts it to numeric if it can, this character will return a false if it is numeric. That's why we put a not in front. This exclamation mark converts the logical condition. If it's true, it returns a false, and if it's false, it returns a true. So what we are getting here is, if the character 8 of the variable is numeric, it will return true. So this condition will be met, and what is inside here will be executed. And what are we going to put inside? We are going to put device no equal device, no plus VC8. Perfect. So, with this, we can now make our message much better. Error in Casambi network number and the Casambi network number, and we improve the message. In device number and our variable device no. We continue and will now explain what comes next. The error is, and the error message is one of these. In real cases, this logger.info is interesting, as you know, always for testing that our system is working and to directly see the results in the log. However, in an operational installation, what is done with these errors is to pass them to variables that are later exported. These error messages can be displayed both in the SCADA and on the screens. This way, by looking at an HMI control screen, we could see that there is an error in one of the Casambi networks, in which device of that network the error is occurring, and exactly what type of error is happening. From the most significant, which is the one we saw earlier where the entire device has gone offline, meaning it has disconnected for some reason. And in the case that the device is still online but detects an error, we then show the type of error. When we get to the chapters on designing dashboards in Adquio and the chapters dedicated to studying our Adquio SCADA, we will be able to see how to manage these errors that come from here in exchange variables. In the following chapters, we will see how to export these variables, which we could create here to collect these errors, and how to pass them to subsequent steps within Adquio. So, in this chapter, we have seen how we can handle events differently, with different condition filters from those we saw in the previous chapter. We have seen how we can use this different way of handling events to apply filters that interest us. Therefore, with this, we achieve tremendous power because with a single procedure, in this case, for example, this one, we are managing all the errors of all the Casambi networks we have connected, of all their devices, and we are extracting exactly what type of error occurred, in which network, and in which device. Okay, down here we have the final example with all that information. On one hand, we handle the error and convert the error number to a valid string. So on one hand, we handle the error. On another, we get the Casambi network number. And in the middle, we have the extraction of the variable, which is simply the device number in the Casambi network. Okay, to summarize, we finally see in which Casambi network the error occurred, in which device of that network the error occurred, and finally, what type of error occurred in text form, with a human-understandable explanation. All right, very well. With this, we have concluded Chapter 8, where we saw a new error management approach. We saw a new instruction, which is the new switch command to evaluate different values and act accordingly based on the content of a variable. As in this example, we also saw the new condition is nia n to check if a value is numeric or not, and we learned how to obtain characters from a string, as in these cases. All strings are arrays in JavaScript, so we can directly access an element of that array, always starting at 0. That's important. As you can see, we have fulfilled the promise. We talked about error management and continued learning a bit more JavaScript so that you have more tools in the future to create your own scripts. All right, we'll see you in Chapter 9, where we will see how to export information in Adquio to send it to our control screens or our SCADA servers, both our Adquio SCADA server and our Adquio SCADA cloud. See you in the next chapter.